It's great to have here on this panel. We have here, representatives from three projects that are layer twos. I guess you know me, Ellie from StarkNet. We have here Professor Ed Felten from, originally Princeton University, and now co-founder and chief scientist of Off-Chain Labs, which is the team contributing to the development of Arbitrum. And we have Daniel Lubarov, co-founder of Polygon Zero. And I'm going to use my my phone just to go over the questions that we have here. So we'll start by some discussion, and then we'll leave room for questions. So the first question is, how did you get into this whole area of blockchain scaling, and what's your project doing today? So Daniel, do you want to?
Sure. Yeah. So before all of this, I was working at Google and just getting a bit bored with the typical engineering problems there, and then I became very interested in zero knowledge and cryptography, and especially with projects like Zero Cash or Zcash, and then started co-founded Mirror Protocol with Brendan, and then after a while, we decided that instead of trying to build something completely new that's not compatible with anything else, it's better to focus on Ethereum and provide proofs for Ethereum, and that's when we joined Polygon to build this zkVM at Polygon.
So for me, I got into this through academia. In the very early days of Bitcoin, I got fascinated by the proof of work mining algorithm and the question of whether the things that Satoshi said about it in the original white paper were actually true. And that led to an interesting line of research, and that one of my colleagues summed up by saying that this is an algorithm that works in practice but not in theory. So I continued to do work related to blockchain, and at some point I heard about this idea of smart contracts. And I thought this was the coolest thing ever. And it reminded me a lot of the moment when people made the web programmable. And suddenly the web was a very different thing. It became a platform that, as we know, we basically use for everything now. So it seemed to me right away that smart contracts were going to be a huge development, really important, but then not long after, the question arose of, well, how could this possibly be scalable? And so that led to the very early work that ultimately resulted in Arbitrum. The first version of Arbitrum was actually built by a group of students as a course project in the fall of 2014. You can go on YouTube and look at their end of semester presentation, and you could see kind of the germ of what eventually turned into the product. But of course, it's a long journey of first academic research and then building and looking for product market fit and all of that to get to a fully built system.
So I'll be both a moderator, but also I'll be a panelist, so I'll answer also. I got it to this thing also from academia, and I was doing first theoretical research and then implementation of proofs, PCP-based technologies. And I was looking for use cases for them. And for a very long time, even as this research was progressing, I dismissed Bitcoin. But at some point, it was really for seeking examples as to what this technology can be applied to. I started eventually looking into blockchains. And then for me, the moment that changed my life and career was a visit to the Bitcoin conference in San Jose, where sort of I had this very strong gut feeling that the technology that I was working on can be very useful in blockchains. And around that time, it was also, Professor Felten and I first met in Princeton because I was giving talks at various academic institutions, and we chatted a little bit about zero knowledge proofs and research and stuff like that. So the next question I have is, so this is a panel about scaling. So can you, LE5, explain like on 5, how your technology works and how is it going to scale blockchain? Let's start with you, Ed.
Sure. Okay. So the first piece of this is that you scale by moving as much as possible of what would happen on a mainnet like Ethereum off-chain. But of course, the trick is to do that, to move it off onto the computers of ordinary users, where execution is much cheaper and resources are much more abundant. But you need to find a way of doing that without giving up the security that you expect from a shared consensus blockchain. And so the key question is, how can we move as much as possible off of that mainnet, and while still having an anchor in the security of that mainnet? That's the basic technical approach. And then within that technical approach, we ask, what is the cheapest and simplest and fastest way to provide that security? And then there's a lot of more complex technology that even 5-year-old Ellie might have taken more time than this answer should take.
Please, Daniel.
Yeah, so basically, in a conventional blockchain, we verify the state of the chain by just re-executing every transaction, seeing if we get the same state root at the end of that. And the idea of ZK rollups or succinct blockchains is just, instead of re-execution, we cryptographically prove that each transaction was done correctly, or that an entire block was done correctly, and here's the state root that results from executing this block. And I guess kind of comparing the two solutions, I think they're similar in that the goal is to avoid an Ethereum user doesn't have to personally verify what happens on any rollup, right? That's the whole goal. And maybe it's just a different extreme where for a ZK rollup, we take it to the extreme where a transaction is executed only once and nobody else has to check it at all. Of course, there are some pros and cons where generating this cryptographic proof takes some more time. So there's that trade-off. But yeah, that's the idea, is basically execute everything only once, and we pay a cost for that. But after that, then there's no re-execution.
My LE5 explanation of the technology is that think of Ethereum as this very trusted computer. It works really well, but it's also very slow and very expensive. So what if we could, and right now it's, without rollups, it's processing each and every transaction, which leads to congestion and cost. What if you could use that very trusted computer in a different way to inspect the integrity of computations, but doing so with very minimal cost? And the short of the story is that there are mathematical ways to make it happen, and they're very surprising and based on very deep and important mathematical innovations. But there is a way to take a very weak computer and let it check the integrity and ascertain integrity over an exponentially greater amount of computation. And that's how we scale with validity rollups. We scale Ethereum. So my question now is to each of you, and then I'll also answer it. Well, maybe I'll start with this one. Like, what is the bottleneck currently, and the pain points, and how will they be solved soon? So I can share our own bottlenecks and pain points. Surprisingly, they're not in the proving technology. So the provers can probably reach today, scale and capacity of thousands of TPS. But our current bottlenecks reside around two things. One of them is the sequencer, which, as its name suggests, it is a very sequential machine. And as you know, we came out with a new virtual machine and programming language, and making the virtual machine and a sequential operation of it fast is our current bottleneck. We recently have improved it a little bit. There are other very exciting projects to improve it even further. For instance, one of them, spearheaded by the amazing Lambda class team, is the MLIR compiler that would take Cairo code directly to x86 instructions. The other pain point is data availability, which sadly, validity rollups actually do very little to solve that problem. They solve very well the problem of computation, but they don't really have much to say about, or not much to compress data availability. So one thing we're doing very shortly is adding the option of off-chain data, but it's going to be a pain point or a bottleneck also in the future, even if we have off-chain data. So that's my short answer to what are the pain points and what we're doing to solve them.
Sure. Let's see. I would also identify data availability. Currently, the flagship Arbitrum chain, Arbitrum 1, uses Ethereum for data availability, which is very secure but also expensive. It's going to get cheaper. But we also have a technology that does off-chain data availability through the Arbitrum Nova chain. And eventually, I think we're going to get with data availability where we are for many of the other functions with these chains, meaning that you can get it down close to the cost of just providing data availability commercially on the internet now, right? You can get that down to AWS-ish prices. And I think that's possible. There's not a fundamental barrier, I think, to being able to do that. So that's a problem I think will be addressed over time. I think there's a whole set of issues that I think many of these technologies have to deal with, which is about the user experience and the developer experience. Historically, blockchains have been unusual animals. All of them have been unusual animals. And have tended to use custom technologies for development, custom compilers, and all of these sorts of things. And I think we really need to do more to unify ourselves with not only with the large mass of programmers already out there who are familiar with other programming tools, but also with the tools that they use, because the compilers, the debuggers, the testing harnesses, and so on that are out there are so much better. I'm going to take this moment to give a tiny plug for Arbitrum Stylus, which is designed to address exactly this problem. I'm not up here to show my product, but we did announce it today, and we think it's important, so I would urge you to go and look at it. Let me then just finish up by talking about user experience. It's also the case that blockchain tech is not very user-friendly. If you cut and paste something from one window to another and you leave one character off, it may be that all your money is gone. There are many stages to processes. If you do them wrong, a lot of things can happen. It's very unforgiving compared to almost everything else that users do online. And we need to find a way to make that smoother. And some of that is just thinking carefully about the interaction design. But also, I think we're going to need to do things in the core technology to support a more friendly and less harsh user experience.
Daniel.
Yeah, so I think with ZK rollups like ours, kind of the expectation is that proving would be slow and expensive, and I think for that we should probably distinguish, like Polygon has a type 1 and a type 2 or 3 prover, and for the type 2 or 3 prover, which is able to modify the state format that the blockchain uses, proving isn't really a huge deal. It's pretty quick. It costs a small fraction of a cent to prove one transaction. For type 1, there are a lot of performance challenges there because we can't change anything in the state format, so we have to prove a huge number of catch-I caches, RLP serialization, and all of this other stuff. But yeah, besides that, I think overall proving is becoming less and less of the challenge, and now it's becoming more of the traditional blockchain challenges. Things like how do we need a better client that doesn't have so many I/O bottlenecks, and all of those more classical problems.
So my next question is 5 years out. What is the scale of your technology, and where are the bottlenecks 5 years out, if you had to guess? Ed, do you want to go first? Maybe?
Sure. I think what will happen, and I hope what will happen, is that we are all scaling our technologies along every dimension. there's enough space for growth that I think, and this means several things. It means making the individual sort of single-threaded chain as fast as we can make it. And a lot of that has to do with thinking about sequencing and node operation, as well as sustainability issues like state growth. I think we'll be working on all of those things to make that single thread faster. I think we'll also be moving towards some form of sharding or a sort of tightly coupled consortium chains as well in order to get another form of scaling. And then finally, we're going to have, I think, a proliferation of more chains that are more loosely coupled. And it's going to take a lot of work to figure out how to make that ecosystem relatively smooth and user-friendly. But I really think in order to get to the scale we can get to, we need to have all of those forms of scalability. So I expect all of those to develop. And we're working hard, and I'm sure other teams are working hard as well on trying to figure out how to do all of those things. I think going forward, honestly, I think proving will seem less and less important compared to all the other things we're working on. I think we can see that happening already. That is, of course, you have to have a prover. As we like to say, we would never release a test net without a working prover. I think it's table stakes. But once you have it there, and if you have a high quality team that's working on that and really sweating over the details of it, certainly these teams are, then I think it's really about how you drive scale and about all of the other aspects of building an end-to-end user-friendly system.
Maybe I'll go second. I'll say that I think that 5 years out, I'm always optimistic. So I think the way things will progress is that at any given, my analogy is things like bandwidth. So think of this now as transaction bandwidth or compute bandwidth. I think that with every iteration of improvement of the technology, the system will get congested shortly after. And the reason it will get congested is that because there'll be new use cases and new applications. So if you think about, wireless bandwidth, it's probably always somewhat congested, but now we do, video calls all the time, and of course send, long videos of cats or whatever it is. And 5 years ago, or maybe it was 10 years ago, it was also congested, but it was congested with, email and maybe voice over IP and things like that. And I think that's what's going to happen, let's say, with StarkNet and with rollups in general, that you'll get, if you think it like rate of transactions, they will keep going on, hopefully indefinitely, or for a very long time, and you'll just have more and more use cases and reducing costs are going down across many dimensions. Another thing I think that will happen and proliferate is fractal scaling, which means layer 3s, layer 4s. The nice thing about validity rollups is that you don't have to the same technology that is already in place, which is recursive proving, can now apply also to fractal scaling, to layer 3s and 4 and so on. And then you'll just have even the main chain of StarkNet will itself carry very little of the load of computation that all of that universe is using. Daniel, your turn.
Yeah, I think I'm mostly echoing what Ed said, but I think in 5 years we won't be talking a lot about proving whether it's ZK proofs or fraud proofs. That will just be largely a solved problem at that point, and very commoditized. I think in 5 years we'll be talking about what I consider the more inherent, sort of truly challenging scaling problems, and that's there are some things like, say, optimistic parallelism, but maybe the biggest would be state growth and figuring out what the solution is to that. And I think that's really Ethereum, something that needs to be addressed for the overall Ethereum ecosystem, because we don't really want individual rollups to be doing their own thing in a way that isn't standardized. So I think that's just a big conversation that the whole ecosystem needs to have, whether it's state rent or some other type of solution.
So my next question, and maybe you'll go, Daniel, first, I'll go second, and Ed last, is about computational models or virtual machines. And of course, you can tell us about Stylus. I think we represent three different approaches to, what is the developer experience in the virtual machine or machines offered. And so what's your approach, Daniel, Polygon Zero?
Yeah, so for Polygon Zero, one of our mandates is to upgrade the existing POS chain that Polygon has. So for that, our goal is to change nothing, right? We don't want to change the gas model or change anything about like the state format or anything about how the EVM works. We just, for now, we're just keeping things the way they are. Polygon does have some more futuristic plans, so things like Polygon Maiden that uses an entirely different state model and uses Maiden as the VM instead of EVM. But there are so many applications already written for the EVM and maybe deployed on the POS chain that we think it's important to focus on upgrading security there before focusing on more futuristic things.
So famously, we went with a very bold and non-trivial choice of, we're a non-EVM validity rollup. Basically, we have a new virtual machine called Cairo that I'm sure many here are familiar with. It's very different differs from the Solidity virtual machine. It's Rust inspired, and the way we came about it was that proving is something that is very heavy in computation. So we thought, and first it was for internal consumption, that the best way to reach maximal scale for our customers is actually to come up with a virtual machine that is best tuned to the constraints of proving, in our case of Stark proving. A little bit just like, CUDA is a language that is very well suited to GPUs and, Android probably to smartphones and so on. So it made sense for us internally. And then we realized that actually, not just internally for Stark X systems, this could work, but also for the world. And that's how we reached the non-trivial position where we reached. We're very happy to see that developers around the world are eager to explore this language, and many of them are actually saying that as a smart contract language, it's a pretty smart contract language. But Judge is still out there. We went down a non-trivial path of diverging from existing virtual machines with their tooling, and we'll see how it plays out. What about you?
Sure. So we started out basically trying to provide a value proposition of a chain that works just like Ethereum, only cheaper, faster, and with more throughput. That is really focusing on compatibility with Ethereum. And for a couple of reasons. One is we wanted to make it as easy as possible to bring applications and application developers on board. And so those who were in the Ethereum ecosystem already knew how. But also because, but the other thing that we knew from the beginning was because in our proving methodology, in the common case, all the prover does is execute, that essentially we needed to optimize our execution engine for the same thing that traditional execution is optimized for. So what that means is we didn't feel the need to change the execution model in order to optimize anything. So we did reach that of having, I think, really good EVM compatibility. There are some necessary differences, such as differences in the economics. If you saw Professor Nissan's talk this morning, he talked about some of the reasons why layer 2 chains have to have slightly different economics. But once we had that, I think, well established, we sort of turned to what we saw as the next stage, which is what we call EVM+. And what that means is retaining compatibility with EVM, but adding the ability to write smart contracts in other languages and then upload them. So this is what Arbitrum Stylus that we just rolled out this morning does. It allows you to write smart contracts in Rust or C++. You can compile them to WebAssembly and then deploy them directly onto an Arbitrum network where they can run alongside EVM contracts. They're fully interoperable and fully composable. it works the way you would hope. We really feel like this opens up a new front in the battle to bring more developers into this space. There are about 100x as many Rust developers as Solidity and Viper developers put together. And in addition, the WebAssembly execution engines are much faster than EVM engines. So you get much more familiarity for people, you get a much better performance. And we think this is really a great model. And not just in principle, but but we've tried to deliver it. And again, Stylus is out there. There's a running test net right now, so you can try it. And thank you for your indulgence with the extra time.
Yeah.
I appreciate the opportunity.
Thanks.
And congratulations on Stone. That's a similarly impressive step.
Thank you. So maybe I'll do one more question, then we'll open it for 5 minutes for questions from the audience. So we're still in crypto winter. So why, and what will the next summer look like? So maybe.
Yeah, I think there's a lot of problems that need to be solved. So some on scalability, but also a lot of less technical problems, legal challenges, and making sure that things like what happened with FTX can't happen again. So I think part of the answer there is just custody is a big problem. If I'm trading, most people who are trading are using centralized exchanges, and even if I'm holding ETH on Binance, I should be able to have that behind my public key, right? But today there's no way to do that. I just have to trust Binance to custody my assets. And then I think the other side of that is we need way better self-custody tools. So that right now you can use hardware wallets or maybe something like Gnosis, but then say I'm using a hardware wallet to sign Gnosis transactions, and then my wallet doesn't really understand what it's signing, and I think that's a big problem. And just I think that's just one of the huge hurdles that we need to overcome before this can become very mainstream.
So AI has had winters, and the internet early on had winters, and why should we be different? Unfortunately, this is a thing that happens, that public opinion can fluctuate a lot. The opinions of sort of the broad markets can fluctuate a lot. But just like in those other fields, during the so-called winters, they didn't happen because the technology was slowing down. They didn't happen because people were not building interesting and exciting new things. It was just a mood swing of public opinion and broad markets, and the mood will swing back. I think where I sit, I feel like we should all continue building, that there will be another summer and then another winter. And the important thing is to keep building and keep making things better.
Yeah, I agree with what you both said. I think certainly part of the winter is well deserved in the sense that there were some very spectacular failures, famous ones, Luna, Three Arrows, FTX. So there was that. There's also seemingly a lot of overreach by certain regulatory bodies, and it's heartwarming to see that judiciary branches are, doing a pushback on behalf of, human society, and putting the executive branch in check, and that's also something. I think what's going to happen in the next summer is that because all of these layer 2s are going to already be out there with their scale, is that we'll see a lot of new and surprising and interesting use cases that we can't right now forecast. So now I think we have time for one or two questions. So maybe, or one question from the audience. So, yes.
So you guys all enable scalability on top of it. What apps are you guys excited about on top of this platform?
I'll just repeat. What apps we all scale on top of Ethereum? What apps are we especially excited about?
I hesitate to name one. We love all our children equally. in terms of areas, obviously DeFi is big. I think there's a lot of room for growth in gaming. Gaming is a really exciting area, and this is one of those areas where increased scale and decreased cost really does. There's a sort of a threshold that the technology can cross, and it just opens up a new type of application. And I think we're basically crossing that threshold about now for on-chain gaming with what's happening with the scaling solutions.
Maybe I'll go second and you can close. If I look in the past, I've been following crypto for about 10 years. I always spectacularly failed to notice or predict, the next big thing, be it CryptoKitties or ERC20s, and ICOs or Uniswap and so on and so forth. So the reason I'm saying this, I think the really amazing thing, or these applications that I'm routing for, are ones that I don't know what they'll look like. I think they won't quite look like what already exists. There'll be something different that really massively uses scale, but I don't know what it's going to be.
Yeah, I had a similar thought. I think it's maybe the creators of Ethereum, they were just trying to build something very general where they had no idea what would be built on top of it. And I think that's very exciting, that kind of unknown and unpredictability. And I feel the same way about some of the ZK tools that we're building, where we're building these very general tools that could be used for this or this or this, but we really have no idea which ones will take off. And that's the fun.
Okay, so with this, I want to thank again Professor Ed Felten, co-founder and chief scientist of Off-Chain Labs, Daniel Obarov, co-founder of Polygon Zero. Thank you very much.
Thanks.
Thanks, Sally.